KD practice problems. So we've got a crate is gently placed with 0 initial velocity onto a moving conveyor belt. So you can go ahead and read the rest of that. Talks about the coefficient of kinetic friction. I want to draw the FBD KD. So what you can do is pause it and give it a shot on your own, and then restart when you're ready. So I will start with crate A. All right, 2 pictures of it on both sides. I've got over on the left-hand side all the forces. So I've got the weight of crate A, got a normal force from the belt, and I've got a force of friction that's going to be being applied to it. So if I look at the impending motion right there, so that bottom part's moving that way. So impending motion would be a slip going that way relative to the belt. So the force of friction would be acting to the right. And then over on the right-hand side, I would have the mass times the acceleration. So I'll use mass of A times the acceleration of A. And you could, again, you could draw the acceleration in the other direction. Either one would be correct. We would end up figuring out what its direction and value is based on the equilibrium equations. All right, now we've got a complex system here. We've got 2 blocks that are resting on a conveyor belt. All right, so this would be a system of particles. We're actually going to draw 3 different free body diagrams here. We're going to do the free body diagrams for A and B together, and then we'll also do it for them separate. So if you want to go ahead and pause it until you give it a try on your own. That's an angle theta sitting right there. They both have a weight. So go ahead and try it on your own and then unpause when you're ready. So I'm going to start with my 2 blocks. Here's my equal sign. End up with a coordinate system on here. I'll end up putting it at an angle. We'll get a lot better at that. That'll be at some angle theta. So what forces do we have over on the free body side? I've got the weight of block A. I've got the weight of block B. I've got a normal force applied to block A. I've got a normal force applied to block B. And again, these blocks are at rest, right, on the conveyor belt. Then suddenly the belt starts to move. So now we've got this friction that's occurring. So before the belt is moved, force of friction would be in that direction. Right? Force of friction would be holding those things on the belt. That belt starts to move. Right? That belt is going to deliver force of friction. I'm going to call it force of friction to block A, and also the force of friction to block B. Those would be very different from each other. Over on the right-hand side, I'm going to have the mass of A times the acceleration of A, and I'll put it in the x direction. I'll also have the mass of B times the acceleration of B in the x direction. All right, and these would all be at an angle theta right there. So those are our FBD, KD for both blocks together. Now let's take a shot at doing blocks on their own. So let's just do block A on its own. So what do we have here? I've got the weight of block A. I've got a normal force. I've got that force of friction on A, and when I remove block B, I've exposed a normal force between blocks A and B. Over on the right hand side, I've just got the mass of A times the acceleration again in the x direction. So I'll go ahead and put my x, y at an angle theta. So there would be my FBD KD for block A. And let's go ahead and do it for block B. So block B, a little bit smaller up there. Again, still at an angle theta. What have I got? I've got the weight of B. I've got a normal force. I've got the force of friction, B. And I've got the normal force, right, acting between blocks A and B. So there's my force, and here I've got also the mass of B times the acceleration of B in the x direction. So there's our set of FBD KD for this system. I've got a 2-block system, right? I can draw A and B together. I can draw block A on its own, and I can draw block B on its own. And obviously these things are going to relate, block A and block B, or relate to each other by that force NAB. So the question is, says, how do you determine if A and B remain in contact? So let's just kind of talk through that. Do they remain in contact? Well, they remain in contact if the normal force is greater than 0. If it's equal to 0, then they're no longer touching. And if they remain in contact, then we would know that the accelerations would also have to be the same. So what we would do is let the accelerations be the same, and you're going to solve then for NAB, and if it's greater than 0, then they remain in contact.